Good afternoon. I know you have been anxiously awaiting my screencast on this. So here we go. We're looking at a graph, and there will be a graph on your quiz that you have to analyze. So let's look at the first thing, that's domain here. And we're going to think about, is there a start and a stop to the values of x that could be along our graph? And it's going to be an interval, so it should just be two numbers, a starting point and an ending point that are x values, that we can see x values at. So if I look at my graph, I can't put a cap to the left side of this graph. There isn't an end to it. So I know that my x's start at -infinity, and I don't see an end to my x's either, so they go to infinity, and infinity always has closure of parentheses. Now the next thing we're going to look at is the range, and I'm thinking about y values now. I'm thinking of the lowest possible y value over this entire graph, and it goes down forever. So it's the smallest value of y. Well, there isn't one. Well, that's a low value of y here. It's only in a small area. So when we go over the whole range, the lowest y, or least smallest y I have is -infinity. And then the largest y value I have is up at 3. And I'm going to put a bracket around it because there's actually a point there. So I want to include 3 as my maximum y value. All right, now going into absolute maximum value. So that's saying what y value, what function value is my largest y on this entire graph. So the largest y value I have is up at 3. And I'm just going to write that y point. My absolute minimum value, well, I don't have an absolute minimum y value, right? Going way down and way down, I don't have one. So we're going to state none. I'm going to check if this is a function next. And for functions, remember, we kind of draw a vertical line through the graph everywhere. Like if I was to draw a whole bunch of vertical lines, if I'm only hitting the graph once, then it's a function. So this one's a function. Now I'm looking for local max value. And in this case, I'm looking for all of my hills. I'm looking points where I can, find a maximum point and both sides be lower than it. So if I'm looking here, I have a max value of 2, and it's at x equals -3. And I'm following along the graph. Well, that's not a maximum. I'm going up top here, and that's also a local maximum. It's a maximum in this little local area. So that max value is 3, and that occurs when x equals 4. Now I'm looking for local min value. Well, nope, that's in -infinity there. So I'm coming up, that's a maximum, and here's a local minimum value. And the local minimum value is -2. That's the y. And then it occurs when x is 0. So now that I know that information, I'm going to think about where is my graph increasing? What's the interval of increase? So an interval, remember, is a start and a stop. It's not 2 points, it's a start and a stop. And in this case, we're looking for the start and the stop of our x's where my graph is increasing. So when we're increasing, our y's are getting bigger. Here's another increase, my y's are getting bigger. So I'm looking for, where does that interval start and stop? So I'm coming from x's, well, I don't see a start to those x's. So I'm increasing from -infinity up until when x is -3. And I'm always using parentheses here because I'm not including that maximum point. That maximum point, it's not increasing or decreasing, so we're not including it. That's why we have parentheses. And I'm going to put a union symbol because I know I have another area where it's increasing. And that increases from when x is 0. And it's increasing until x is at 4. Now we're going to do our interval of decrease. So I'm decreasing now. So I'm going here. And I'm also decreasing here. So where am I decreasing in between? Well, when x is -3, I start decreasing until where x equals 0. And then I'm also decreasing from when x is at 4 until, well, I don't see the stop to the x, so it's at infinity. And the last thing to talk about is the end behavior. What happens at the ends of this function? So we're going to use the notation as x goes or approaches infinity. Well, as x approaches infinity, well, x goes to infinity out in this direction. So as x is approaching infinity, where's y going? Well, y is approaching negative infinity. So as x gets bigger, y is getting smaller. And then our next side, because we have to have two sides to the graph, that describes what happens when x gets really big. What happens when x gets really small out in that direction? So as x approaches negative infinity, our graph, the function value is going down. And I'm going to use f of x because we should be able to use both of those. So f of x is approaching negative infinity.